Hello and welcome to another video. In this video we're going to be working on longest palindrome, and in this one you're given a string which consists of lower and uppercase letters, and you want to determine the length of the longest palindrome that can be built. Letters are case sensitive, so AA is not a palindrome, so here they show you one you can build that length is 7, and here's A. So essentially, what do you need to have a palindrome? That's kind of like the main thing of this question. So for a palindrome, the word needs to be the same way forward as it is reverse, right? So as we're putting letters down, like let's say we have a palindrome like this, and we're putting letters down on the end. So this letter and this letter need to be the same. And then as you move in, they need to be the same again, like this. And this needs to keep happening, right? So you basically need to have pairs of letters that are exactly the same in order to do this. And if you have pairs of letters that are exactly the same, you can just put one of the letters on one side and one of the letters on the other side. So something like this. And a palindrome can either be odd or even. So if it's even, it's going to be just like this. Or it can be odd, where you have these pairs and then you have one letter in the middle that you only have one of. So let's say I have, 5 pairs, and then I could throw in like one letter in the middle, like letter number 6. Or I don't need to have it. So knowing that, how do you do this thing? So all we really need to do is for each letter, we need to get a count of that letter. And how many times can we use the letter? So let's say we have, for example, let's just do an example. Let's say we have like let's pretend we only have lowercase. So let's say we have 7 A's, 7 B's, and 7 C's. So for A, we have 3 pairs. For B, we have 3 pairs. And for C, we have 3 pairs. So we can make a word with these 9 pairs, right? So for A, if we have 3 pairs, so we can, it doesn't matter like how we make it, but essentially let's just say we have like A, B, B, C, C, C. So that's 3 pairs. Sorry, that's the 3 singles. And then on the other side, we can do the same thing. So something like this. That would be like one way to build a palindrome, and then we can combine this, and that would be our palindrome. So essentially, basically like this. So because you have 3 pairs, you can put one of each on each side and like make this. So knowing that means for sure, like if I have some number of pairs, I can just count up the total number of pairs I have. So let's say I have like 20 pairs. That means I can make a 40 length palindrome, because I can take my pair and I can put one number here, 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 and so on, right? I can just split my pairs, put one number on one side, one number on the other side, that makes a palindrome. Now, you can also use an extra number, right? So we can have one other thing, one other letter that we can put in the middle if we do have an extra. So for example here, let's say we had, like let's say in here we do have extras, because if we have 3 pairs, we have an extra A, an extra B, and an extra C we're not using. But if we only had 6 of each of these, then we can make an 18 length palindrome, which would be like this, and we can't have anything extra. But the extra letter in the middle can be anything. So as long as we have an odd count of any letter at all, we can use that as an extra, but we can only use one. So if we have 7 A's, 7 B's, and 7 C's, we can only use one extra one of these. So our count here would actually be only 19, because we could have 3 of each pair, and then we'll take one of each, like one letter to put in the middle. So we can have, for example, we can have an A in the middle, or a B in the middle, or a C in the middle, but we can only have one. So that's kind of the solution. So basically the number of palindromes is number of pairs of letters plus up to 1 extra if we have it. And that's basically it. So this is like the formula. So how do we, now that we know that, like how do we do it? Pretty easy. You can just make a hash map. So you can make a hash map of all the counts, and then all we need is the values. So let's say we have 7 A's, 7 B's, and 7 C's. We don't really care what letter, we just care about the values. So let's say our counts are like 7, 7, and 7. Then we could say, okay, here we have 3 pairs, here we have 3 pairs, here we have 3 pairs, so we have 9 pairs, which is 18 letters. And then we can just have a Boolean value of like, is one of these values odd? And if one of them is odd, we have the extra letter. And that's basically it. So we're just going to make a hash map. I said before, in Java, it's better to make an array. So instead of making a hash map when we make an array, it's going to be more performant. And with an array, the index will just be the ASCII value minus, so here's an ASCII chart. So we can just do the ASCII value minus this uppercase A. So for example, uppercase A will be at index 0 because we can offset everything by 65. And then it looks like lowercase z is 122. So if we do 122 minus 65, that's like 50 something. So we can just make a array of length 60, and then the index of the letter will just be the ASCII value of the letter minus 65, because uppercase A is at 65 and z is at 122. So for example, R will be at location 114 minus 65, and A will be at location 0, and then this guy will be at 122 minus 65, which is a little under 60. So we need an array of length 60, and then we will just increment the like location there, and then we're going to go through all the values in the array and get the total count for the palindrome. So let's do that. So we can say int array counts equals new int array. And even though there are 60 here, like let's say every letter is the same, we're still saving the overhead of making a hash map. So in general, if you can in Java, you want to make static arrays. That's going to be your fastest stuff. Okay, so we're going to go through all the characters in S. So and knowing this, how to build the longest palindrome is going to be useful for harder questions. So like all I care about is the pairs. I don't really care about what palindrome I build, but for every pair, I can include all of that. So here we're going to say what our like location we'll say or something equals S character at A, or a character at I minus A. So basically it'll take this value minus 65, and then we need to convert that into an integer. So that's going to be the ASCII value offset by this guy, which is what we want. Then we can say counts location plus because that's where the character is going to be. Then we need to oh, that's screwed up actually. It needs to be like this. Yeah, so there we go. This should be good now. Okay, so so now that we have this, what we need to do next is we need to actually go through all of these, and then we need to see like how many pairs and singles and stuff do we have. So we'll say int pairs equals 0, and then we'll have like int maybe call it extra character or something. We'll say it's false, and we can loop through all of the counts in here. So for int count and counts. So for number of pairs, it's pretty easy. Or this needs to be a Boolean. For number of pairs, it's pretty easy. We can just do pairs plus equal count divided by 2, right? Because an integer value in Java divided by 2 will just truncate the decimal. So if we do like 7 over 2 an integer, that'll give you 3.5, or it'll give you 3. And then for the extra, we can say extra equals, if we already had one, then it's going to be true. Or we'll say count over, and there's a bunch of ways you could write this, but this is one of them. So basically, if we do have an odd value, it's going to be true, or if it was true before, it's going to be true. Then finally, we need to return. So for every pair, that's 2 letters. So pairs times 2. Plus, if we have the extra, then we'll add another 1, and if we don't, we'll add 0. So one way to write it was like this. And there we go. And yeah, so if you actually did this with a hash map, it would be slower. So yeah, generally better stick with an array. But if the array doesn't make that much sense, you can use a hash map. Hash map's more intuitive, and then you just have the character and its count, and do the exact same thing here. So this is going to be, so we're going through the whole string S. So that's going to be of S. And then we're going through the counts, but keep in mind that even though the string is like 2,000 characters, there's only 52 characters. So this array is only, or I guess length 60. So yeah. So it's going to be constant. Like the string can be 1,000,000, and the array will always be 60. So this is, you can basically say this is O of 1, or this is O of 1. And that's why I'll say the space is O of 1, because no matter how long it is, we only have 52 characters max. Yes, that's going to be all for this one. Hopefully it was helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.